In this video, we are going to look at von Neumann architecture. This may be a term you haven't come across before, but don't worry, you'll know everything about it by the end of the video. But before we do that, let's have a quick history lesson. This is the ENIAC, the world's first computer. These giant machines are fed data while they are running. The problem with these computers, though, is they were only hardware. This means there were no programs stored on these machines. They also could only perform one task at a time. And if you wanted to do something else, you would have to rewire the device. That was until 1945. A man by the name of John von Neumann had an idea. He developed the idea of a stored program computer, known as von Neumann Architecture. This idea is how computers in the modern day are now run. Let's take a look at this now. Von Neumann Architecture was a concept which involved storing programs and data in memory. Data would then move between the memory unit and the processor. Does that sound familiar at all? Hopefully, because the device you're using to watch this video is most likely using the von Neumann architecture. Before you see a diagram of von Neumann, it's important you understand more about buses. So, just remember that a bus is a wire or a cable that is used to transmit data or signals. We've got three here that you need to know about. The first is the address bus. So, an address bus, as you could probably guess, is used to carry signals relating to addresses between the processor and the memory. Effectively, it says where a particular item of data is stored or should be stored. This is a unidirectional, so it only travels in one direction. Then you've got the data bus. So this sends data between the processor, memory unit, and the input-output devices. This is bidirectional, meaning it moves in both directions, which actually makes a lot of sense, because when you input data, it goes into memory, and then the processor will do something with this data, and then hopefully produce an output. This requires both directions to be used. Easy. Finally, you've got the control bus. This carries signals relating to the control and coordination of all activities within the computer. Okay? And this is unidirectional and bidirectional, really depending on the connections within the computer. That's an interesting bus there, I think. Alright, so here you can see a typical design of the von Neumann architecture. It shows clear links between the processor and memory units. Each of the buses are used for their own purposes, as shown previously. You may want to draw this diagram in your book or digitally. Pause the video here to give yourself time to do this. We're about to look at a more complex version of von Neumann, but before that, it's important you know what is meant by the terms address and register. An address is the location of where data can be found in a computer's memory. Each address in the memory is unique. You'll learn about registers in more detail in another lesson, but in its simplest terms, a register is a high-speed storage area within the computer. Here is a slightly more detailed diagram of the same concept you just saw. In this model, we use registers, which have been labelled in the lighter green boxes. While addresses are part of the architecture, they are not shown in this diagram, but they are part of memory and control units, which you'll know as an address is a location in memory. Do not worry just yet what those registers stand for. You might be able to tell some of them, but don't worry just yet. We will look at those in another lesson. And that's everything you need to know for now about von Neumann architecture.